Okay, so this problem is actually a little bit longer than the last one. So I think it might be time to start diagramming some problems out. As the problems get more complicated, it's actually very helpful to start figuring out what you need to do, okay? So the first thing that we're going to do is we're going to determine the limiting reactant. And kind of as we're doing that, we're going to be, or in order to do that, we're going to be finding moles of each, then moles, convert that to moles H2, and finally we'll go to grams H2. Okay? So the first thing that we're going to need to do in order to do any of this is we need the balanced chemical equation. So metallic magnesium reacts with steam, okay, vapor or gas, yields magnesium hydroxide plus hydrogen gas. Okay, and then I need to balance this. I have 2 oxygens over here and 1 over there, so I'm just going to put a 2 out in front. Okay, and then we're balanced. So the next thing that I'm going to do is I'm going to do this weird trick where I answer how many grams of hydrogen are formed, and I'm going to use that to determine the limiting reactant. Okay, so question mark grams hydrogen equals 16.2 grams magnesium times 1 mole magnesium divided by the molar mass of magnesium, 24.305 grams magnesium, times 1 mole H2 over 1 mole magnesium times 2.016 grams H2 for 1 mole H2. And that equals 1.34 grams H2. Okay, and then for the second one, I'm still going to find grams H2 because this is still a limiting reactant problem. Start with my 12 grams of water. Okay, and now a lot of this stuff's going to be similar, so make sure that you're using data more than once. Okay, so I will have to look up the molar mass of water. Okay, so I'm going to put my grams of water down here, and I can't go straight from grams of water to grams of hydrogen, right? So I'm going to go through moles of water. And this is molar mass. So the molar mass, the coefficient in front of the mole is always 1. And this is 18.015. Okay, and then I'm going to put moles H2O on bottom. And I'll convert from moles of H2O to moles of H2 using the mole ratio. So it's 1 to 2, 1 over 2. Okay, and then I'm just going to use the same value, right? 2.016 grams H2 for 1 mole H2. and this equals 0.671 grams H2. Okay, this is less than this, so this is the answer. Okay, that means that water is the limiter. Okay. And then, so that's C done, okay, because this was C, and also A done. So now I can do B. How many grams of the excess are left? Okay, so the excess reactant is the magnesium. Okay, so in order to figure out how much is left, remember I need to do magnesium that you started with, or that you had, minus the magnesium that you use, and that's the magnesium left over. Okay, so we need to find how much magnesium was used. So that's question mark grams mg equals 12 grams water. Okay, and then I already have a lot of stuff done here. Okay, I already have a lot of numbers up here, so I want to make sure that I use those. For instance, I have the molar mass of water up there, 18.015 grams H2O and 1 mole H2O. Okay, I can go moles H2O to moles of magnesium. Okay, so now I need to go up to the balanced equation. 2 moles H2O to 1 mole magnesium. And then, so let's cancel out some stuff. So I'm at moles magnesium, and I need to go to grams magnesium. Okay, and I got the molar mass of magnesium earlier, 24.305 grams and 1 mole. Okay, and I calculate this out, and I get 8.09 grams magnesium used. Okay, I know so now I'm ready to plug some stuff in, right? I can put that in right there, but I actually want to do this up there, so whoops-a-daisy. All right, so the magnesium that I started with was 16.2 grams. That was given in the problem. Okay, this 8.09, that goes mg used. That's had. Okay, so when I do the subtraction, I get 8.1 grams mg left. Okay, and significant figures, remember this is subtraction, so I'm going to line up and use decimal places. 8.1 grams magnesium left. Okay.